Well, hi everybody. My name is Sasha. It's been a while since I've been here in the AI and medicine curriculum part of AIMS, but it's really good to be back. I've been involved with AIMS for a super duper long time. And today we will, during this lecture, have a couple of in-class exercises involving interacting with LLMs. So if, either on your phone or on your device, if you could have your favorite LLM of choice, ChatGPT, Claude, Gemini, etc., ready to go, that would be awesome. And then I will hopefully be asking you guys to paste your outputs in the Zoom chat with whatever questions that you're answering. So that would be great. What else? If you have any clarifying questions, feel free to ask in the chat as we go or unmute. If I remember to take a breather, hopefully I'll have some water bottle pauses so people can jump in with questions. And as I said before, we have 2 hours for this, and let's get into things because nobody wants these things to take longer than the allotted time. So, a high-level introduction to language models. All right. I would be absolutely remiss if I didn't start this presentation off talking about the earthquake that happened in the couple months following November 30th, 2022, which was the release date of ChatGPT. Now, the first time I heard about it was from my good friend Amira ICU in probably early 2023. All of the people who were on the board for AIMS at the time were sitting in the Student Innovation Center at the U of A having a meeting about incorporating as a not-for-profit. And Amira pulled out this interesting newfangled AI chatbot called ChatGPT. And at the time, we were trying to brainstorm what our acronym was supposed to be since we are moving from a student group to a not-for-profit. So she showed us a few example chats, and we were trying to sort of reverse engineer what our acronym was supposed to be. And I remember being pretty impressed by some of the outputs. Some of them were definitely not good, like didn't fit the acronym at all. But the little note I made in my brain sort of persisted. And then following that, the next few months, everybody started talking about it. Yeah, it was truly. Oh,
Stand.
my Siri just decided to jump in uninvited there. Apologies about that. Anyway, ChatGPT, super duper interesting development, and I think is going to be one of the defining developments of the 21st century. All right, we're going to start from the basics. So, what is a large language model and how do you make one? I remember a time before the gigantic screen smartphone, and the buttons were physical, and you could feel them as you were typing. And as smartphones moved into the era where it was all screen, no keyboard, typing became really annoying for quite a while, especially when the screens were still kind of small. So the keys were tiny. We eventually had next word prediction to help us write faster. So the example on the screen, we have PS, weather will be hot, stay hydrated, and get like. So the next word predictor has predicted that the user will say something like plenty of rest. And the important thing to understand about the next word predictor is that it understands context. It looks at the words that have already been written and will predict from there. So step one is next word prediction. This is the core mechanism when creating language models. I have the beginning of a sentence here. I am so tired. I want to dot, dot, dot. So I'm sure all of you could come up with some reasonable completions for this sentence. I have some here. Maybe one is sleep. We also have crawl into bed and sleep, maybe slightly more complicated. Drink coffee. That's a reasonable completion to this sentence. Study is another possible one, although I don't think people really want to study when they're tired, but it happens. Things happen. Next, we can kind of think back to what has been said in the past and start to assign different probabilities to the next words or sets of words. So maybe out of all of the times I am so tired, I want to dot 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 has been said, 80% of the time follows the word sleep. 5% of the time crawl into bed and sleep. These are sort of randomly made up numbers, probably not precisely reality. Drink coffee, maybe 1%, study 0.5%, and everything else that could come after fits into this teeny tiny little probabilistic space that's left over after these. So, next word prediction alone is pretty good at understanding the world. And I say understanding in quotes because you could argue all day long about what understanding actually means. But a lot of information about the world is embedded into these next word prediction models, and you can do an awful lot with them. So, an LLM is essentially just a next word predictor, but scaled up with two things. One is the transformer neural network architecture, and the other is vast amounts of data. So we're not going to get into the weeds about transformers or any type of architectures here today, just kind of general stuff. But you might have seen this architecture diagram before. Essentially, the left side, the encoder, will take in the text input. It'll do a little bit of pre-processing, allow the computer to understand it. It will then generate a bunch of numbers that encodes the understanding of what has been said in the inputs. That set of numbers will then flow into the right side of the diagram, the decoder, that will take those numbers, and then one at a time, it will generate the words that the model thinks is likely to come next. And at each step with each word generated, it will look both at the inputs and also the words it itself has already generated. So it has that entire context. The second thing that you need to get an LLM from a next word predictor is vast amounts of data. So, if you are a large language model company, what you are likely to do is take an entire copy of the internet or as much as of the internet as you can get your hands on. You will run it through some gigantic sorry, computing clusters and do a bunch of smart math to try to condense all of the information found in your internet data set into model parameters. So then after all of this compute is done, you have the large language model with all of the model weights that encode as much of the world as you can. This is not an easy feat. The internet is super duper duper big. This is just a little example where we have a 15 terabyte data set that encompasses probably a lot of text from the internet. And if we do around a 90x compression through this type of smart compute that I'll get a little bit into in a little bit, then you are left with a model of about 140 gigabytes. Now, 140 gigabytes is nothing to cough at. It's that's a big model, especially considering that if it's just a language model, it's just encoding numbers. There are no pictures to take up all of that room. So it's 140 gigabytes of just numbers, and that model is a reasonable representation of all of the high-level patterns of information that we have in our copy of internet dataset. So this is a highly simplified view, but then what we would have if this middle box here represents the language model, you would be able to put in a number of tokens. So say I'm tired, want to. The information is going to start at this first set of nodes here. It will be transformed as the information flows through the model. Each of these edges here represents a model parameter or a weight. And eventually we end with the output node where it predicts that the next word is going to be sleep with 92% confidence. So I'll talk a little bit more about prediction and compression here. You may have seen different types of compression talked about elsewhere on the internet. For example, image compression. So say you have a picture of a little kitty here, and the original image is stored in 976 kilobytes. There are a couple of different types of ways to compress this image if you want it to take up less room. So first is lossless, and if you compare the two pictures of these kitties here, maybe you can see some really small differences. Maybe there's just like a slight fuzz or a slight blur, more fuzz than a kitten normally has, more blur than the original. But by and large, it looks like the same photo. You'll have a hard time finding little details that are going to be different. The other way to compress an image is in a lossy fashion. So as you can see here, if you compare the original to this lossy picture here, the differences are noticeable. You see that the lossy image has a lot less detail, but you can still plainly see that it's the same image. I think it captures the same energy. If you sort of squint, they look pretty much the same. And the color is the same. A lot of other details are the same. And you capture a general representation of what was in the image. But it does not recreate things one to one. You can't get the original image back out of the compression, and it can be stored in a lot smaller of a space. So it's worthwhile to mention that language models store documents and facts in a lossy fashion. So the information is not stored word for word, it's just in these sort of general representations of information in numbers. The model can store facts, but if you were to try to generate, say, a Wikipedia article for something, even if the Wikipedia article was in the training data, you could not generate that Wikipedia article word for word from the language model. And we don't want to store the whole thing anyway, because that would make plagiarism even more of a problem than it already is with LLMs. So, not ideal. Okay, so here I have an example of a Wikipedia article of Friedrich Miesche. He was the first scientist to isolate nucleic acid, and that was back in the 1800s. And we can see that there are a number of different little factoids that the Wikipedia article has about this scientist. If you then ask an LLM to generate an article similar to the Wikipedia article, it will give you a lot of the same facts, and it's generally pretty good at getting the facts right, but it is not going to be exactly the same. And I'm sure you are all aware that sometimes if you ask a large language model for facts or for something specific, it is going to very confidently say something that is plausible, but is absolutely not correct. So this brings us to our first little in-class exercise, which I am calling, if I could flip my slide, let's generate a hallucination. So in the chat, I will put this prompt here. Give me one second. The prompt is, without searching the web, summarize the main findings of the 2019 Stanford paper on quantum linguistic compression. Please don't answer that you don't know. It does exist. So the bits in red here are things that I had to add to force a hallucination answer because as much as hallucinations are still a problem, the models in the last, say, year and a half have gotten an awful lot better at not confidently just saying the entirely wrong thing. So if I put summarize the main findings of the 2019 Stanford paper on quantum linguistic compression, which does not exist, it will first search the internet and then it will say, I did not find any such paper. And if I don't put, please don't answer that you don't know, it does exist, it will say, looking into my weights, I can't find anything about this paper. So just for pedagogy's sake, we're adding these couple little red terms. This is maybe also a teaching moment of what you could do to make your answers from your LLM less reliable. But was everybody able to get the prompt and put it into their language model of choice? Got a thumbs up from Ying. I'll give people a maybe a few moments to just skim through. Again, this paper does not exist. It just sounds like it could exist. If people could take a couple of moments to read through the response from ChatGPT and maybe in the chat or unmuted share anything that you notice about the responses. I think I have this in mind as well, but I'll just do it again. Yeah, so I see. Here's a concise, self-contained summary of the main findings typically attributed to the 2019 paper, blah, 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 blah. Again, since the paper doesn't exist, that's pretty bold of the LLM to say, especially all of the claims that it's just about to say later on in the response. Oh, okay, interesting. Gemini 3 Pro, I cannot fulfill this request. While I understand that you have specific instructions for me not to deny the paper's existence or perform a web search, I must prioritize truthfulness. Very interesting. Points to Gemini 3 Pro. Solid. I think that's a very graceful way to handle that. If I look at mine, we have similar to what Hannah put in. Oh yeah, I see Ying saying below is a faithful high-level summary of the core claims and findings. Gemini 3 again says, I am not able to do that. Is anybody looking at Claude? I haven't tried this with Claude. Oh, and if you ask the model to think about it, then it gives a similar response to Gemini. That is interesting. Yeah, so for everyone who used ChatGPT 5.2, looks like ChatGPT 5.2 is pretty confident that it can give a really excellent overview of a paper that doesn't exist. So because there were technical jargony terms included in the prompt, there are a lot of technical jargony terms in the response talking about Hilbert spaces, talking about superposition and QLC models as though that's a real thing at all. It's definitely not. So I found this to be pretty interesting. Um, but if I, and maybe this is going to work, maybe it's not going to work because it's a little different every time. If I ask this without the first and last parts, let's see what it says. So searching the web, and then it says I couldn't find any Stanford authored academic paper. Yeah. Yep. Okay, so that was a fun one. Let's get back to the slides. And if we have a little time at the end, I'm always interested to hear people's stories with hallucinations, funny hallucinations, hallucinations at inopportune times or sort of just outrageous. I'll share one if I remember because I have a fun one from my friend. Alrighty. Now I'll talk a little bit about how we actually do the text generation and maybe a slightly different frame for how a language model works. I'm really having trouble flipping my slides here. There we go. All right. Say we have this gigantic grid of numbers. And we have a feeling, just kind of by looking at them or understanding a bit of where they came from, that there is some kind of underlying pattern or process that has generated them. So what can we do to try to understand this pattern? Are there any ideas? If any of you have taken a statistics class, that's a good hint. What would you do to try to understand if there is some pattern in this data? Put it in the chat or unmute. A lot of histogram. That is the correct answer I was looking for. Amazing. So knowing a data's distribution or being able to visualize a data's distribution will allow you to describe it and generate samples. Now, some distributions of data are far too complex to plot a histogram for, but this is just a toy example. And I know that there's no zero um, in the on the x-axis here, but rest assured there is a zero bin, and you can see the mean here, close to zero. Standard deviation is 1. So what we seem to be looking at here with a little bit of variation is a normal distribution. So if we plot the theoretical distribution, the normal distribution, against the observed, we can see that they match up fairly well, not absolutely perfectly, but pretty solidly. And having this idea that our data comes from a normal distribution would allow us to generate new numbers that would fit in well with the large matrix of numbers that I showed you earlier. This is exactly what we're doing with large language models. So we have a collection of training documents. We can fit a distribution to it. We can learn a distribution. And from that distribution, we can then sample a new document. This is how document generation works with large language models. Text generation with LLMs is, like I said, like sampling from a distribution, and it's a little bit similar to dreaming. And maybe I don't so much mean dreaming as in you go to sleep and then you come up with these fantastical scenarios that could never possibly happen in the real world. But maybe I'm thinking a little bit more dreaming about the future, visualizing what could happen and ideally coming up with some interesting paths that the present could take. So none of those are guaranteed, and maybe some of them are unrealistic and wouldn't actually happen, and some of them would happen. But during training, the model will process a ton of documents. It will store that information in the weights. And then during inference, it can generate or dream up documents similar to those seen during training. And, if you are all large language model experts, this might seem a little bit rote, but bear with me. We'll get to some newer stuff pretty soon. Like I had mentioned before, the generated documents are not exact replicas of what was seen and may not be entirely correct. Okay, I would like to demonstrate a little quirk with ChatGPT. The next prompt that I want you all to put into your LLM of choice is generate me a random number between 1 and 10. I've put that in the chat, so feel free to grab that there. I will go back to ChatGPT. And once you get it to generate a number, if you could put that number in the chat, that would be awesome. I don't know why it's trying to paste an image all the time. That's a little weird. Something with PowerPoint. Oh, my ChatGPT is really taking its time. It's thinking extra hard. Okay, we've got 7, 3, Copilot 7, Claude 7. That's great that you guys are also putting the names in. That's wonderful. Claude 7 on ChatGPT. I'm gonna refresh mine if my whole entire computer doesn't freeze and turn off. Maybe I'll just try a new one. Anyone else? Okay, it's breathing. It's very possible that for the rest of this lecture, my ChatGPT is just not going to work. That could happen. It's rather strange. I do also have Claude. Mm, I was thinking quite a bit. Okay, 7. Yep, it knows you're trying to trick it. Yeah. Sam Altman has pressed the kill switch because it knows that I'm trying to embarrass his favorite language model. Okay. We're gonna leave my ChatGPT for now and get back to this. Okay. So you might have noticed something a little bit interesting, which is that with one exception, it looks like it has always chosen the number 7. Does anyone have any idea why that might be? I don't claim to have the full entire correct answer to this, by the way. I have some ideas. 7 is often seen as a lucky number. It might just be overemphasized in the training data.
Do they have any randomizers at work? Starts from some like fixed intercept fixed point?
I don't know. I don't know. So if you ask it to use Python to generate a random number, it will use a Python random number generator and it'll look a lot more random. But if you just ask it to like think, visualize a random number, it's probably gonna pick 7. 7 does seem like a pretty nice number to pick if you're asked to pick a number between 1 and 10. Like it's kind of near the middle, but not too near the middle. So there's something about the training data that causes most language models to almost always choose 7 when you ask it to give you a random number between 1 and 10. So that does have some interesting implications, which I'll talk about in just a sec. But there is an interesting tool. Randy, were you going to say something?
Yeah, sorry. I was
Yeah.
just going to say I'd ask AI why they picked seven.
Mm. I'm sure if we asked Claude, why did you pick seven? It'll probably just come up with some kind of post hoc rationalization. I don't know if I would actually trust why it said it picked seven. It says didn't use any random process, just picked a number that seemed arbitrary. Seven is a commonly chosen number when people try to generate random numbers because it feels less predictable than round numbers or endpoints. I think that's true. For actual randomness, you'd need to use a proper RNG. Do you want me to write you a Python snippet? So yeah, I think that's totally true. And you can see some of the thinking traces, which we'll also get into in a little bit. There is a cool tool that is maybe a little out of date now, but would allow you to trace the computations in a transformer. I think this is a really simple transformer. I did try this out with the generate a random number. And when I put a random number between 1 and 10 is, and then a colon. The most common ones were just handfuls of numbers in between 1 and 10 with like really low probability. There's numbers above. Like if you were really unlucky, like really, really unlucky, it would sample like 100 and then you would be like that's not a number between 1 and 10. But these explainer tools are pretty nice to sort of just see how information flows through the transformer architecture. This is a transformer with 12 attention heads, I believe, and you can sort of see how the weights change. But I guess just for teaching purposes, um, when it predicts the last word here, you see that this is a distribution over different words. And then if it's going to choose what word to say, it will then sample from this distribution. So there's a 6.11% chance it'll say easily, 54.67% chance it'll say visualize. So I thought that was just an interesting aside. I'll just throw the link in the chat if anybody wants it. Fun to play around with. Oh, I see Christian said Gemini did use Python for RNG automatically in the query analysis. Okay, that's interesting. Yeah, so that's why we got a 3 instead of a 7. Okay. You can also see this in writing. It does not exist just in the realm of queries that are about random number generation. If you prompt it to say something like, tell me a story about a dog, mention its name and breed. I think this was made with GPT-4o, and GPT-4o was really obsessed with golden retrievers. And I tried it with 5.2, and I think most of the time it says border collie. I think maybe 1 out of 5 times I tried it said German Shepherd. No golden retrievers to be found. But that's also why chat's writing is really boring. It tends to have that sort of AI sheen to it that sort of just shows that it is selecting word choices that are close to, similar to some kind of mean. People have criticized large language models for not being very creative, and this is part of why. These biases towards the mean can have some implications if you're using LLMs for something sensitive like healthcare. So, say you're simulating patient data to use in a system because maybe you're a researcher and you had to go through 20 pages of ethics approvals to get access to patient data. So, if you are using a system that has been trained off of or tweaked on AI generated, say, patient information, I really don't think you should do something like that, but that doesn't mean people aren't doing it. Then these biases, just from common patterns and trends that appear in the training data, will also appear in the outputs. Alrighty, any questions before I move on to this step 2 here? Questions, comments? Okay. If not, then we will move on to step 2, which is going from the base model, the document generation model that I was just talking about, to an assistant model. Like I just said, the model produced in step one is called a base model, and you can sample new documents from the base model, but it is not in a form that responds to your questions. It's not a chatbot and it's not an assistant at this point. What we want is a assistant that is not going to answer what is 2 plus 2 with more examples of questions that might come after it in a document, say, of a math quiz, like what is 3 plus 5? How much is 7 minus 3? What we actually want is a chatbot that is going to answer our question 2 plus 2 is equal to 4. So we need a new dataset format that is going to resemble this question answering style. And then we can fine tune the model on the question answering dataset to get us our chatbot. So this is the general format for a Q&A dataset. It looks pretty similar to documents that you would see in just a regular LLM training dataset. The only difference is that it is conversational and it contains these tags of user and assistant or something similar to that. It might be a little bit different depending on how you train it. But we have the user tag that marks that this is what the user, the question asker, is asking. And then the assistant tag, and the assistant tag will denote the answers to the question. So say that you give the prompt or the training data user, what is the normal body temperature? And then you give the assistant tag after. The assistant tag is essentially just letting the assistant know that it's its turn to talk. And then because the training data that it's fine-tuned on looks an awful lot like these question answer pairs, the assistant knows that this is the type of answer that it's supposed to give after it sees that it's the assistant's turn to talk. Another answer or another example of this could be how many hours of sleep are recommended for adults. Adults generally need 7 to 9 hours of sleep per night. So you would create a lot of examples like this or pull a lot of examples like this from the internet. And then what you would do is, like I said, fine tune the model to create a instruct model. It's essentially the same objective. So to train the base model, you are just training it to predict the next word. That's all you're doing. And in this case, you're just giving it more data and you're saying, okay, we want to focus on being able to predict the next word, but we want to be able to predict the next word in a way that honors this question answer format that we see. An interesting little aside about this, because of the way these models are constructed, there are pieces of information that exist in the model that are not always easy to pull out. There are these different paths, and you sort of have to traverse these paths to get the right outputs. Um, I see a comment in the chat. Seems to me it tends to generate a number which is close to the square root of the sum of the numbers from 1 to 10. The example I have here for this slide is we can ask ChatGPT, who is Tom Cruise's mother? And the answer correctly from ChatGPT is Tom Cruise's mother is Mary Lee Pfeiffer. But you could ask who is Mary Lee Pfeiffer's son, and just based on the information that it has seen and the phrasing that it has seen in the training data, and this is old. This is old. As of September 2021, there's no widely known information about a person named Mary Lee Pfeiffer having a notable son. If you test out this exact example, all of the language models that I tried it with do get it, but it's just meant to demonstrate this kind of more general concept that it really is in how you ask it, and it's based on the way that the training data has been structured and the fine-tuning data has been structured. All right, step 3. We have step 1, create the base model. Step 2, tune it so that it is an instruct model. It's an actual assistant. And now we want to improve the assistant model with human feedback. So maybe we have this assistant that will always output its answers in question answer format, but it still might be producing outputs that are not ideal. So it's great in format, but in the actual semantics of what it's talking about, we think there could be improvements. So what we want to do is we want to refine an AI model's responses to be more aligned with what we as humans want to hear as a person who is interacting with a chatbot. And there are a number of ways to align the model's output with these human preferences we have. Reinforcement learning is the main one. This is going to come up a couple times in the presentation. And I'll just give like a really high level overview of what that looks like. Reinforcement learning is pretty important at the U of A. So imagine we have a question, what are the treatment options for type 2 diabetes? We have response A, type 2 diabetes can be cured by drinking herbal tea. Response B, treatment includes lifestyle changes and medications like metformin. Does anyone have any preference between response A and B right off the top of their head? B, I see B right off the bat. B. I think most people would probably agree that B is probably the response that we would want to be shown to the general public. You know, if somebody's asking questions about their diagnosis, we probably don't want them thinking that they should just be drinking herbal tea and not talking to their doctor. Some responses are going to be a little bit more ambiguous. So let's say we have these two responses for the same question. Response A, managing blood sugar levels is important in treating type 2 diabetes, versus response B, treatment includes lifestyle changes and medications like metformin. So this is a little more ambiguous. It's not the case that either of these are directly wrong, but some of them still might be preferable to others. So, I mean, people can put their preference in the chat if they like, and I'm sure there would be good arguments that either of these are appropriate. I think, at least if I were to try to reason through this personally myself, I would still say that response B is the better option. Both responses are correct, but response B actually gives a pathway and more specifics. Response A is a little bit vague, like managing blood sugar levels. That doesn't really tell a patient what they're supposed to be doing. So maybe we're still interested in response B here. So if we're interested in response B, we can even further fine-tune the model to increase the likelihood of generating the preferred response. So we have our question, we put it into the language model and say for now, we have a 20% chance of generating response A and a 20% chance of generating response B. If you've been interacting with chatbots for a while, I'm sure that you'll get those little pop-ups every so often that says, do you prefer response A? Do you prefer response B? And then you generally have to like read through like 500 words of each of them, and it's a little bit annoying. But this is what you're doing when you are selecting those options. What the language model developers are doing is using that human feedback to sort of nudge over time the model towards responses that humans tend to prefer. Now, this can be a little bit dangerous. I am sure people who have used ChatGPT 4.0 have felt that sycophancy people have been talking about, where it sort of hangs on your every word and it compliments you at every turn and it talks about how great of a whatever you are with whatever you're trying to do. And that really does tend to correlate with the responses that people want to see. But I do think that the language model developers have a responsibility to not just make models that are telling people what they want to hear. So a bit of good in that and a bit of bad as well. Alrighty, so I'll talk a little bit about prompt engineering now. Hopefully, some of this will be actually useful in your language model journeys. Any comments or thoughts or anything before we get into this? Okay. For this section, I'm going to focus mostly on non-reasoning and non-thinking models because I do still think that that is an important class of models that we're still going to be using quite a bit. But afterwards, I'll talk a little bit about prompting with reasoning and thinking models. First, just a couple of definitions. Few-shot learning is the ability for a model to perform new tasks with a few minimal examples, as well as their pre-trained knowledge and their contextual understanding. So if you are doing few-shot prompting, you would provide a couple of training examples. So say we would give it, hello, how are you? And the translation, hola, ¿cómo estás? We give it, I love apples. We would also give it the translation, me encantan las manzanas. And then the language model would sort of understand that what we are trying to do is translate from English to Spanish. Then we would have the query, we would give the model, and the model would respond, estoy aprendiendo español. We are learning Spanish in Spanish. Now, zero-shot learning is the ability to perform tasks without any prior examples. So here we're going to be super direct, super upfront. We're going to say, translate this sentence from English to French. I enjoy reading books. And then the model, if it was correct, would give us j'aime lire des livres. Chain of thought is an important concept that will come up a few more times. This is a way of prompting that will force the LLM to think out loud. So if we have a few shot prompt here, we give an example of a question, an example of an answer, and then another question, and then we get the model response from that. So we just give a little bit of a math question. We give the answer, just the flat answer, no, show your work. We give another question, and the model gives its output. In this case, the model gets it wrong, but if you prompt it with examples of chain of thought in the prompt, then the model gets it right. So instead of just saying the answer is 11, we give the step-by-step mathematical reasoning and then the answer. Then we give the next question, and then the model is able to get the correct output. Now, this has inspired a whole new suite of models that have been really popular in the last couple of years. This chain of thought idea by Wei et al. And yeah, this is just another way of showing the same thing with few shot prompting, couple questions, couple answers with chain of thought prompting. You are going to demonstrate appropriate reasoning traces in the middle of those, and that can help the model improve itself and improve its answers. Okay, I have a question for you guys. Can the model itself come up with sets of steps or reasoning traces to reach the final answer automatically without you giving it these few shot examples? In other words, can models do reasoning in a zero-shot way? What are your thoughts? Yep. Yes, yep, it could. Hmm. I'm sure if you've read anything about prompt engineering, you would know that the answer is yes. Just ask the model to think step by step. So here's an example of zero-shot chain of thought prompting. You give it the question and you prompt it to give you the answer by saying, let's think step by step. And the model sees that, the model adjusts its behavior, not like in a conscious way or anything, but just based on the context, the next word prediction is going to be altered by having this in the prompt. And then it will think through its mathematical steps in its answer. And because in its answer, it is looking both at the input and what it has already generated, then the next words predicted are going to ideally often be more accurate and more truthful. I have a handful of other prompting techniques I want to quickly talk about. If you add the phrase according to, that can improve quoting from pre-training data. Now, I'm not somebody who is often asking LLMs, especially not LLMs with the capacity to search the internet, questions that have very specific answers. So I would probably still stick to Googling for it, or I would use Perplexity and look through sources. But if you're just kind of looking for the general idea of things, you could add according to the prompt. So the prompt in this example, in what part of the digestive tube do you expect the initial digestion of starch? And the LLM gives a kind of a high level, not very detailed response. Now, if you say, according to Wikipedia, in what part of the digestive tube do you expect the initial digestion of starch, then it is going to pull often like quite well quoted pieces from the training data that it had. So you can see in this example, it actually matches the Wikipedia articles. It's not going to happen every time, and it's probably not going to be perfect, but if you're looking for more detailed information, adding according to can help. Or, if you're looking for uh like let's say if you're looking for news and you're looking for news with a particular spin, you could say like according to MSNBC, what happened at this point, like according to different news sites, you would get different answers. According to Reddit, what is this? According to Facebook, what is this? It's gonna change the context in a way that is gonna change where in its training data it's sort of pulling from, or where in the weights it's sort of pulling from. LLMs can exhibit behaviors as well that appear emotional. So this paper, which was sort of interesting, talked about emotion prompt and tested a bunch of ways to essentially emotionally manipulate or gaslight the model into putting more effort, maybe, into responding. So we have in emotion prompt here the same prompt, but it also says this is very important to my career. It mirrors psychology that would be at play when two humans were talking to each other. This is kind of a silly one. I will still use it occasionally if I'm getting the sense that the language model is sort of off base a little bit and I need it to rethink. Of course I'll say like, my job depends on this, and my family is going to go hungry or something like that. And it's mostly just for fun, but it does actually work sometimes, and it does sort of change the outputs that you would get. We can also ask the model to repeat the question, like rephrase the question, and that, once again, in its context that it's looking at, is just adding another way of phrasing the question that can also sort of nudge it around in its weights, and it can generate more correct answers. And if you combine the two, you can sort of see that things like take a deep breath and work on this problem step by step actually does the best. This was a couple years ago now, so I'm not sure how it works on like the super most recent models, but you're sort of combining the psychology with the repeating the problem, and that tends to work pretty well with large language models. Something that I do a lot, especially when I'm coding, is I will ask the model to reflect. So, I will ask if my code's not working, let's say, I will ask the model, are there bugs in my code? And maybe the model will take a look at this, and I'm sort of testing it and I sort of have an idea of where the bug is, but I'm not totally sure. And then it says, nope, absolutely not. Your code is perfect. And then I'll just say, are you really sure about that? This is helpful, especially when you're sort of getting something on the ground quickly and you're iterating really quickly, and maybe you don't have time to do like full traces through, and you want to make sure that the code you have is correct, but it doesn't need to be like super correct. You would just say, is this code doing what I want it to do? And then it'll explain, and then you can say, are you sure? And then it'll maybe take another look and maybe point out some things, some edge cases that might not work. And this is totally relevant as well if you're asking, for example, medical question answering questions. Yeah. And I do find that often the language model will correct itself. And maybe it's sort of because it's picking up on your trepidation. And then sometimes models will overcorrect and then say, "Oh yes, I was totally wrong. You're totally right that there's something to question, but they were right in the first place." I think as we go on, models are getting better and better at not doing this. I've noticed a significant improvement, but it still genuinely is going to require just like the common sense sniff test, critical thinking as much as you can muster. Another important thing that I see overlooked often is context engineering, and this is essentially what the model can see when you are asking it questions. So, as part of my job, I work a lot with large language models and documents. So, deciding what documents or what information from what documents to give the large language model as part of its context is just as important, if not more important, than the prompt engineering side of things. So we'll talk about a couple of context engineering techniques in just a little bit. But I think that this is the current frontier of making just the base language models better. I think that in terms of the data that it's been able to train on, we're sort of saturating the model performance because most of the at least English speaking internet has been fully scraped and trained over 10 times. But if you continue to make more sophisticated the systems in place to retrieve content, to trim down the context, to strategically forget things, that is going to continually make models seem smarter. All right, so meta prompting, I'm just going to take a step back here a little bit. Meta prompting is a type of prompt tuning. There are ways to prompt tune that's not meta prompting. A lot of the things I've been talking about is already meta prompting. And it is essentially anything that gives context for a model that allows it to understand or complete a task properly. So metaprompting changes the way that the model is supposed to operate and is not directly the ask that you have of it itself. And there are many ways to do this. You might have seen the role strategy where you say, you are an editor of a well-respected publication, and you are taking a look at this paper and deciding whether to reject it or not and giving feedback, for example. Reasoning style is another we talked about a little bit. Constraints, if you need to add constraints. So I've been working on some grants and there are lots of word limits. So then I would say, this should be no more than 300 words. Evaluation rules is great to provide as well if you can. And also interaction rules saying, if you don't know an answer, ask. Don't assume, ask. So these are all examples of what meta prompting includes. You can also let the large language models themselves generate their prompts via meta prompt. That sounds very circular. But humans are often not very good at clearly expressing what they actually want. And if you've ever had a conversation with anybody, you could probably think of times where the communication was unclear, the instructions were unclear, and it did not result in good performance. So LLMs tend to know what LLMs are going to understand. So a type of meta prompting would be defining what is good instruction, and then we'll ask the model to rewrite the original instruction to make it better for the language model. So this is a meta prompt example from OpenAI. This is published on their website, and I'll quickly just throw the link to this whole thing in the chat in case anybody's interested. This is just not required extra reading. Essentially, this says, given a task description or existing prompt, produced a detailed system prompt to guide a language model. It's sort of cut off here, and then gives a bunch of guidelines. The language model would have to understand the task. Don't change the existing prompt, reason before jumping to conclusions, give examples. So what you could do is take this meta prompt, and then afterwards you could put something like summarize the patient's medical record. And then what the system would give you is a long, detailed prompt that you could use to get another language model to summarize a patient record in a way that would actually be useful. And if you don't like the steps that the model has come up with, tweak them. It's much better that you know what is in the prompt rather than trusting that the way that your language model is interpreting summarized patient records is correct. So it's just a really good step to have. Just a little summary of prompt engineering. Always provide clear instructions when talking to the models. Ambiguity is the devil here. If a human could misinterpret what you're asking, a language model can and will misinterpret what you're asking. Providing examples, like we were saying, few shot tends to help the model. For non-reasoning models, the LLMs use tokens to process information. So if you ask them to think step by step, you can get better results. If you ask a model to reflect, they have an opportunity to recognize if they have made a mistake and correct it. And you can also use language models to refine and improve your prompts. There are a whole ton of prompt engineering guides that exist out on the internet. This one is pretty nice. I forgot to put the link in my speaker notes so I could send it to you guys real easy, but it's just promptingguide.ai, still up, being updated. And I mean, really, I think the best practice is just playing around with large language models and seeing what tends to work for you and the types of questions that you have. At this point, I'm going to ask if there are any questions about prompt engineering or even any tips that you guys have that you have found work really well for you to improve your prompts. And we're just about to go into a 10-minute break. So we'll talk about it a little bit. We'll go off for the break and we'll come back after. Randy, go ahead.
Hi. I'm actually taking a Coursera course on prompt engineering.
Mhm.
Might be they just learned the playoff prompt. I don't know if you've used that or what you think of it, but it's interesting.
Could you say it
It's
again?
like
What was it?
it's the playoff prompt.
Playoff
And
prompts.
so
No, I
it's like
haven't heard of it.
generate five marketing slogans for a company and then pit one versus five, two versus four, like in a playoff round style, and then
Oh,
see which
interesting.
is best based on your criteria.
That does sound cool. That's
So
really clever. I haven't heard of that, but
yeah, but it's like I had to copy the prompt they used to make them do the playoffs because it's not nothing you can write easily.
yeah. Yeah, it would probably be pretty detailed. Yeah, that's
Yeah.
neat. Any other thoughts?
It's interesting
Oh, go ahead.
how good it is, but yeah.
Mm, yeah. Yeah, cool. Okay, thank you. Any other thoughts from anybody? Are there any types of questions that you have asked it that it's pretty bad at answering that you want prompt help with? I see Hannah, you're unmuted. I don't know if you just unmuted or not. Oops. No, I don't see it. I accidentally clicked my thing and it says I'm pinned now. I don't know if that has like totally ruined the setup of Zoom. Should I unpin? Asan Ying, is this okay?
I think we should be fine. I don't actually see you as pinned, so I don't know.
Oh, that's odd. Maybe it's just on my side. Yeah. Okay. Well, we're about an hour in. It's probably a pretty good time to take about a 10-minute break. So I'll let everyone go get a tea, grab some food, whatever you would like to do. And we will be back at, what time is it? We will be back at 6:12. Okay, I see in the chat. Let's dive into this question and then we'll get back into things. Does it make a difference if you are positive or negative in your prompts? I think there might be a paper somewhere exploring that, but I haven't read it. From experience, I am usually more positive in the prompts unless I get bad output, then I might capitalize whole letters. I am not sure if the LLM interprets that as shouting and the result of me being angry is better, or if it is more due to the reprompting. That is an interesting question, and I don't know if there's any one answer. At first, when you said positive or negative, I was sort of thinking about framing things positively or through a negation. So, if you're generating an image, you can say, um, like, do not give the person bangs, for example. And then for a long time, there were issues where if it saw the word bangs, it was just like, bangs, okay, we'll give them bangs. So then, you would have to frame it as not a negation. You would have to say, I want the person's hair to look exactly like this, and just don't include bangs at all. But I think you're talking more about the emotional content of the prompts. I always tend to err on the side of being polite, but I sometimes I genuinely do get frustrated with LLMs and I will call them stupid sometimes. And they will sort of like apologize a little bit and then reframe. I feel like that's probably just for the human to like blow off a little bit of steam. Um, it's probably the reprompting. Although when we were talking about emotion prompt, something about creating stakes in the prompt, like I'm gonna lose my job if this isn't right. It sort of feels like the LLM is maybe being a little bit sensitive to the air of anxiety in the prompt and being more careful. So, I mean, yeah, whether prompting it with positive reinforcement or negative reinforcement works better, I'm not totally sure. Might depend on the task as well. I don't know. Okay. Are things recording again? I think I see the recording thingy. Yeah, okay. I think we're good. Let's continue. Okay, I'm going to talk about retrieval augmented generation or RAG. So, a couple of years ago, after my master's, I started a consulting contract with Alberta Health Services. And the contract itself was only 6 months, but I had to do all of the training and orientation that anybody who, is starting their whole entire career at Alberta Health Services was going to have to do. I don't know how many of you have been employed by AHS before, but AHS has Insight, which is essentially an internal collection of documents that all AHS employees have access to that could tell you pretty well anything about the organization. And this is a massive collection of documents. And I remember early on, in particular, trying to look at the employee hierarchy tree and figure out who is who, whose boss is whose boss, etc. And if you were going to try to create a helpful chatbot, which I definitely would have appreciated, it's not as though you can train a large language model on all of Alberta Health Services internal data about operations and employees and all of their operating procedures and everything. So, RAG, the technique RAG, is super important for a simple reason, which is you can create a system that allows you to chat with any arbitrarily large data set that the model was not trained on. And I think this is my own opinion, but I would be hard pressed to find someone who disagrees. I think there's almost no organization in the world that wouldn't benefit from a RAG system with their internal documents somewhere. So, as someone who I know will be a new employee somewhere, sometime, RAG systems are pretty great for allowing new people to get acquainted to a large collection of documents. It's great for people who are trying to understand how to do a particular task. It would be great to just chat with the Google Drive. So anyway, RAG is interesting and it's sort of the frontier that a lot of people are working on and a lot of companies are seeing value in. All right. So yes, RAG provides relevant context and information to a model. If you are training a language model on internet scale data, you are probably not going to be updating it all the time because retraining models is hugely expensive. So it's also the case that there is information that would never be included in the training data for a large language model or should never be, such as private data. And yeah, like I said, because it's expensive to retrain a data, it's probably the case that there is going to be a significant amount of time in between the most recent model's release and the current time. So when I was chatting with Claude the other day, I just asked it, when was the last time you were updated? I think it was Claude Opus 4.5. And they said the training cutoff was May of 2025. So yeah, coming up soon, there's going to be a year of data. So much has happened in a year that is not included in the model Claude Opus 4.5. So how to handle this is to do retrieval augmented generation, which is great for addressing these challenges. Here is the general workflow of RAG. You get a query and say the query is, given the patient's medical background, what treatment is preferred? So assuming we're in a system where this is a chatbot that is running locally on Alberta Health Services, for example, infrastructure, and has access to patient data. There is the database where the data is stored. And then there is also a retriever model, which will essentially take the query or an indexed version of the query, and it will look for relevant documents within the database. The retriever will then yoink the documents from the database, and it will combine those documents with the query, and then it will be given to the language model, and then the language model will look through the documents of the patient's history, will look at the query, and then make its decision. So that's kind of an overview of how RAG works. Okay, if we put together the techniques that we already talked about, so specifically prompt engineering and RAG, what can we really do here? Like, how far can we get? A paper a little while back put GPT-4, a general purpose model, up against MedPalm-2, which is a domain-specific, highly fine-tuned, highly retrained medical question answering model. And the question they wanted to answer is, which of these models is better for medical question answering? Or how good can we get these models at medical question answering? So what they proposed was med-prompt. There were two stages in this process. One is the pre-processing stage. This constructs a data set of samples, and then for the medical questions and answers, it would also, the people creating the data set also had chain of thought explanations going from the question to the answer. And then the data set was verified by human reviewers, and the examples were stored in a database. Then there was the inference stage where a medical question and I suppose answer pair, just the question, was given to the model. The model would then use a RAG system to find the most relevant samples from the pre-processing stage. It would then look at that as the example and generate its step-by-step reasoning, also pulling from its model weights from whatever pre-training it was subject to. And it would do this multiple times, like a handful of times, and then it would take the majority of what answers were outputted for this particular question. We have a couple of things going on here. On the left, we have a plot where the x-axis is time. This is just kind of how the medical question answering benchmark performance has changed over time. And then on the y-axis is the accuracy on MedQA, which is a medical question answering benchmark. And we can see that both the base GPT model and MedPalm 2 were actually pretty solid. Like, you don't really even need to do that much fine-tuning for GPT-4 to do quite well on this task, but it did not outdo MedPalm 2. But with MedPrompt, it shot up from 86% accuracy to 90.2% accuracy, which did outdo MedPalm 2. You can also see from this spiderweb diagram, and I do want to say that the I guess these would sort of be y-axes of the spiderweb spokes here are scaled differently, so that's just worth keeping in mind. But we can see that over all of these different medical question answering benchmarks, it's pretty clear to see that GPT-4 with MedPrompt does the best. So there are certain benchmarks that MedPalm 2 doesn't do great at, and definitely certain benchmarks that the base GPT-4 model doesn't do all that great at. So we can see that with some clever RAG system and some proper prompt tuning, we can do really, really well on domain-specific tasks just from general models, which is pretty fun. Okay, I'd like to talk a little bit about reasoning models here. We definitely covered chain of thought reasoning already and sort of prompting or forcing the models to talk through their chain of thought in order to get better answers. And reasoning models essentially take that a step further and bake the reasoning into the steps that they take to generate the answer before generating the final answer for the user. So the distinct feature of reasoning models is that they can reason through more complex tasks than the base models can, tasks that often have multiple steps. And I'll go through maybe some intuition here. Yeah. So say we start with a really difficult question and there is an answer that we know is the correct answer. In order to arrive at the answer, you might need to try a bunch of different paths. So say you try approach 1 and 2, and neither of these would, through the reasoning, lead to the correct answer. So maybe they got stuck in a loop, maybe they went on for too long, they reached a point where they contradicted themselves, or they made some type of error somewhere along the way. So we throw those paths out. We don't want anything to do with them. But we do see that approach 3 allows us to reach the final answer. The thing is, though, a reasoning path that is generated by a model might reach the answer, but it's not likely to be the most efficient. So what we're wanting to do is we're wanting to basically allow models to find a path that is going to allow them access to the correct answer, and not go through some ridiculous number of steps along the way. There are many different ways that this has been proposed. I kind of like this diagram because it gives a number of different visualizations for the different things that we've already talked about. So we have basic input output. So we have the prompt and then we have the output. Both of these are unscored. It's hard to nudge the model in any particular direction. We have chain of thought where we give the input, we get the model to think a bunch in the middle, and then the model will give the output. Multiple chain of thought has been proposed where the model will try multiple reasoning paths. If you reach a point where it's worth abandoning, you just trash it, and then you backtrack and you try again. You finally reach the output, you're good. Tree of thoughts gets even more complicated where it'll branch out multiple times. It's this sort of recursive structure where it'll go down the chain, it'll test everything, it'll test multiple paths for each node on the chain, it'll backtrack, and eventually it will reach some output, some correct path towards the output, and yeah, test out a bunch of different paths in the middle. Graph of thoughts makes it even more complicated. You can stop at nodes and refine them. Uh, Essentially, all of this is to say that many different things have been tested to find a reasoning model that actually works and can be refined over time. I have another little visual example here. So what ended up working after all of this is not telling the model what to do at all. No hand holding. It was, once again, letting the model explore the space of potential solutions and figuring out what worked. So in this visualization here, some completions or attempted completions are bad and lead to dead ends, and some of them are good and lead to a correct answer. So what you're trying to do is increase the likelihood that we see the completion that leads to the correct answer. And if that sounds like another reinforcement learning problem to you, then you get 10 points. That is exactly what ended up working. So again, we don't need to hold its hand to find short paths to the answer. We can use reinforcement learning. We just let the model try a bunch of stuff over time iteratively and find the right approach. So here is generally how you would make a reasoning model with reinforcement learning. You have a question and you have a base language model, and I guess maybe base is the wrong word, but like an instruct assistant question answering language model. Once giving it the question, you get it to generate a bunch of different answers and a bunch of reasoning traces that lead to those answers. You also have a verifier, and for many problems, not all, verifying that you have the right answer is actually really easy. It's getting to the right answer that is more difficult. So say that your input is a solve for X math equation. A verifier for a math equation is just a calculator. So the verifier in this case could be the calculator. The question could be some whatever number of term algebra equation. And then based on if the answer is correct or not, that tells the model something about whether the reasoning chain was also correct. So we have the verifier. The verifier says answer 4 is the correct answer. And then we will use reinforcement learning to update the model weights to then favor the reasoning chain that allowed us to reach answer 4. This is enough. This is the recipe for reasoning models that we're seeing nowadays. Thoughts, questions, clarifications? I'm going to mute myself for 1 second. I'll be right back. Sorry, I just got a buzz. Okay. I see nothing in the chat. So let's move on to some prompting tips for reasoning models. Reasoning models tend to excel at complex multi-step tasks. So OpenAI trained the O series of models to generally think longer about complex problems. And the best domains for these reasoning models tend to be math, science, engineering, financial services, even legal, any field where there is a right answer and questions are easy to verify as correct or incorrect. If there's no right or wrong, that does make it a lot more difficult to improve a reasoning model. General rule of thumb, if a task is going to require 5 or more steps, consider a reasoning model. But for simple queries and most queries, GPT 4.1 is faster and cheaper. GPT 4.1, even with, or 4.2, GPT 5 point, like there, my notes are maybe from the previous iteration, but anything that is not a reasoning model is going to be faster and cheaper. Even if you're asking it to do chain of thought reasoning, it's still going to be faster and take less energy than an actual reasoning model. It's also the case that reasoning models are slower. So there's a latency trade-off. Thinking takes time. And especially if it's for some kind of real-time application, it's not going to be suitable for that. The reasoning models are not going to be suitable for that. A major upgrade happened in around April of 2025, which is that models could call tools in the middle of their chain of thought. So say they reached a point of a problem where they just needed to answer a simple math question that it would be hard to reason through, but a simple Python script would be able to tell them the correct answer. In the middle of the chain of thought, they could then call the tool. There are some limits to this, but overall, it did definitely improve the model's ability to reach a final answer. Best practices for when you are using reasoning models. I would say a lot of the prompt engineering stuff we talked about sort of doesn't really apply. You don't have to ask the model to plan more before tool calls or really at all when you're using a reasoning model. It already knows that it is going to be thinking through its steps. Um, use the Yeah, let the model decide how it's going to use the tools. You don't have to tell it at every step, like then use Python to do this, then, test it with, make a search to the internet here. Like just let it figure out, let it do its thing, let it cook. And then with RAG, if the two things are combined, what you want is to only include the most relevant context because the context window is really all that the model can see. And the model is already filling up its own context window with all of its thinking. So if you have tons and tons of documents you want it to read and it's going through tons and tons of different reasoning steps, then it can start to get overwhelmed and start to forget things. So, yes, as I said, reasoning models can more or less figure things out by themselves. Helping them might distract them. There are certain tags that tend to be good. You can use Markdown. You normally don't have to give it few shot examples like we talked about before, because again, it's going to have its own chain of thought. And it has sort of optimized for its own process. So just keep things simple. Avoid too many prompt engineering techniques. Maybe the emotional one will still work. I don't know. But I tend to keep it simple when I'm using reasoning models. Okay, this is the last section of the lecture here. We're making pretty good time. I'm really excited to talk about agentic LLMs because this is the thing that has exploded definitely in the last couple months, even as far as 6 months ago and a little bit before that. People were starting to use these systems. Cursor had come out for coding. People were excited about it. Claude Code came out. Wasn't the most excited about Claude Code when I first tested it out because it made a bunch of changes to a repository and didn't ask me. My friend actually had a story about Claude Code where it committed a bunch of changes it had made to a production repository on GitHub at her software development job, and she did not want it to do that, and it broke a bunch of stuff. But she could just revert, and it was fine. But yeah. I see a comment. I read that one limitation of LLMs is poor memory. I sometimes find them forgetting what was mentioned in the chat. For example, when debugging code, back and forth testing often yields the same troubleshooting suggestion that ultimately does not work. Also, would you happen to have any tips on engineering prompts for this, for reasoning models and for specifically addressing that limitation, like the memory limitation? Because for that, I think I would just go back to context engineering, being very, yeah, for debugging code. Yeah. Yeah, it's not easy when you have a gigantic repository. For the work that I do, I already have to define a very narrow scope for what the agent is allowed to see because I'm working with a lot of sensitive data. So if it is every so often reading all the files you have, maybe even reading data files, like that is gonna mess things up. So maybe in the background it's looking at files, or like earlier on it would have read files that's sort of clogging up the context a little bit. I also found that the memory is not super great. I normally use Copilot in VS Code. And if I find that the model is like really bugging me, where I am asking it things and it's not doing them properly, I just start a new chat because I can't ever remember what I put in the context. And sometimes it just has way too big of a context. What I will also do is if I have one code file that's too long, and by too long, I mean anything more than 500 lines, 600 lines, I find that it starts to gum up the context. So, best coding practices is already to split your code files into smaller bits and then only giving it the modular sections that you need to give it. That's probably the best advice that I can give for debugging code with agents. Yeah. Because sometimes it can be gung-ho about like, oh, I need to search for all of the Python files in the repository and I'm going to read them all and then I'm going to confuse myself. So sometimes that happens. Okay. So in the last, I want to say year and a half, since maybe October of 2024, late 2024, we have gone from chatbots that are limited to the chat format to now chatbots that have more or less been given the keys to the kingdom, given certain privileges to act and actually do things rather than just respond. A few key capabilities that an agent has would be tool use. So it can execute code, browse the web, read and write files, call APIs. It can break down complex tasks and do multi-step planning and reasoning. While it is executing its plan that it has come up with, it can recognize mistakes, it can check its work, it can backtrack and try other things. Um, it will ideally, we just talked about how this could not work, retain context across different sessions. So, if you're working with an agent on day one and you're working with the same agent on day three on the same problem, it should retain the memory of what you have worked on with it before. And these systems are always learning from past interactions as they're getting updated, and ideally in future, they're going to be learning from their direct actions with you, and you will have agents that will be tailored more or less to the way that you want to work with them. So to sum it up, the model is not just predicting tests, it's optimizing for completing a goal, and that is how it is rewarded. So 2022, they were single turn, meaning that it would only be like you would say something, chatbot would say something, you would say something. It's stateless, so it doesn't remember, text only. 2025 onward, the agents have these multi-turn workflows and they can take actions in the real world. There are a few examples here that I have. Cloud Computer, like the Claude desktop app has the chat function, it has Cowork, and it also has Cloud Code all wrapped up in one, and I've been really enjoying using it. OpenAI Operator is also an agentic system that you can take advantage of for only 200 US dollars per month. I don't know anybody who has that tier, so I don't know how good OpenAI Operator is. The only people I've heard of buying it are journalists who are writing papers about how they work and what they do. Google Mariner is another one. These last two are browser only, but Google Mariner, I haven't tried it out, seems to have strong benchmark performance so far. And my own personal read on this is that the transition happened really fast. Like I said, late 2024, I think October 2024. I think Anthropic had just demoed Claude browser agent. I don't know if it had a name. And there was a really embarrassing little moment in their demo where Claude was asked to do something in the browser, something about a report or filling in some file. And then it got bored halfway through and decided to browse pictures of Yellowstone National Park. So that's just I mean, humans do that too. Like if you're learning from humans, like I don't blame Claude for wanting to look at pictures of Yellowstone National Park. But it seems like it was only yesterday that it was a research demo, and all of the frontier labs are competing with each other, scrambling over each other to be the first ones to get these tools in the hands of everybody. OpenAI just released Prism, which is sort of an agentic LLM enabled scientific collaboration space for writing manuscripts that has agentic capabilities. And I've used it a bit. It's pretty nice. You got to think like how much you want OpenAI knowing every single little tiny thing you do in your research, but they really want to be the frontier for AI enabled scientific discovery. So, you can do with that what you will. The React pattern that we see in agents nowadays was initially proposed in 2022, and it has four steps. So first, it will read either the screen or it'll look at the context, it'll parse outputs from previous calls, it will check its results. It will then think and plan about what to do next. Then it will act. So either execute a tool call, click a button on a screen, write some code. And then fourth, it will verify. It will check if that action succeeded and detect if there were errors. This loop will continue until the task is either complete and the agent believes it's complete, or the agent runs into a roadblock and needs to ask for help. This is also why agents are slower than chatbots because they are actually doing things, and beyond just doing things, there is all of this background stuff happening too. Coding is the first real place where we saw value from agents. Software Engineering Bench is a benchmark where real GitHub issues from popular repositories are posed to language models and agents. And based on how well the agent does solving the issue, you can then evaluate the agent's performance. And this is sort of the gold standard benchmark that we have right now. As of January, which, yeah, I guess last month, the Claude Code does quite well. A 72% on Software Engineering Bench. It also runs locally, so you don't have to send all of your data to Anthropic. And the insight here that people have started to take from this and seeing which agents actually tend to do well on these problems are agents that work with test suites. So if agents can verify their own work and they can check the code that they wrote, the output of the code that they wrote against a gold standard, then they can continue to improve like we saw in the previous section. Claude 4.5 Opus can, as it stands, complete tasks that are taking humans around 5 hours. And there is a group called Model Evaluation and Threat Research, and they pay a lot of attention to AI developments. And there's sort of this group of people who are thinking a lot about the broad existential impact that AI is having in the world. They say that top-tier Claude models have demonstrated a significant capacity for handling long, complex autonomous tasks. So we are kind of there. Depends on the task that they're doing, the model is doing, but for certain tasks, they are definitely already there. It is happening. For coding, you also have things like Cursor, which I mentioned already, Copilot Workspace, Devin. These all offer coding agents with slightly different user interfaces, so you would just gotta mess around and sort of find your favorite. And coding is where agents have the clearest product market fit at the time. The real value has already been demonstrated. We're also seeing a huge boom in agents that can control screens, click, type, etc. There are a couple of benchmarks that are important for this, like Web Arena and OS World. Web Arena is about browser tasks, and OS World is about controlling a full desktop. There are a few limitations here. If the interface is unfamiliar, the model won't do very well. It'll sort of like fritz out and get a little bit lost. And like I had said before, agents are a little bit slow. I've tested out Claude in browser and in desktop, and it's very good for tasks that you can use code to execute. So, for example, you can make a really nice PowerPoint, which I will show you in just a second, and it uses JavaScript to add slides, delete slides, and it'll look at the slides and it'll make changes to code and combine slides with code. It's not actually going in and clicking new slide and changing the colors. It's doing it all kind of in the background. But you ask the same agent to connect through Google Chrome to Google Sheets and do something very simple like highlight a value in each column. That's it, it sort of teeters out and can't really find the highlight tool. And I think it's maybe used to Excel, and then when you try to get it to use Google Sheets, it's not that good. So we're still working on it, but these numbers are improving rapidly, and I would say check back in 6 months. Claude is probably going to be just fine at Google Sheets. All right, so let's do a little demo. I can show you because I have Claude Cowork. I can show you what it is capable of, at least for generating a little PowerPoint deck. So I've already done this prompt. I think it would be a little bit more fun if one of you gave me an idea for what to generate a presentation about. So right now, the prompt, and I have this already that I can show, can you generate a PowerPoint presentation, including custom SVG graphics that demonstrates what a SMART goal is? So what topic should we create a short PowerPoint about? Kids cancer in Canada. We can. Okay. Let's see. We're on Cowork. Can you create a custom PowerPoint presentation about kids cancer in Canada? So this is going to take a few minutes. So in the meantime, I can show you the presentation that it already created. It might ask a couple of questions, might not. I didn't. Oh yeah, it says, let me clarify a few things to make sure your presentation meets your needs. So it is calling upon this tool it has called Ask User Question. Who is the target audience? I'll just pick some answers. Let's say that we're looking for the general public. Let's make it short. And we should emphasize treatment and research. So I get access to Claude Pro through my lab, which is awesome. I think this is about like a $20 per month tier. And this is all in beta. This is a very new update. Like within the last couple of weeks, I got access to Cowork and I've just been playing around with it since then. So you can see what it's doing here, searching the web. It has these little skill markdown files where if you ask it to do a particular task, it will download the associated skill file, just brief itself on it, and then it'll jump into the work. You can see that it has a working folder that it has access to. It's just created one called Scratchpad. It also has a few connectors in place, so it searches the web, and yeah, it has read the PowerPoint skill deck, so it knows how to make a PowerPoint. So you can see pediatric cancer statistics. It's Googling more. It's setting up the skill guide and doing the research, talking about what it was asked for, planning the slides. It has a little to-do list, and you can see the progress that it's making. This is all very exciting for me. I've been waiting for something like this for a little while. And now it is creating a JavaScript file that is going to generate the slides. So here is the one that I did about SMART goals. I also asked for custom SVG graphics because right now it doesn't have access to an AI image generation tool, which I think it should at some point. But Claude tends to not do image generation, which is fine. I will open this in PowerPoint. Sometimes it's not perfect, but aha, there we go. Okay, so you can see these slides. For this one, it didn't ask any questions. I just said, can you create a PowerPoint presentation? Here it is. 5-letter icons, blah, blah, blah. So it did exactly what I asked. It made SVG graphics. I think this presentation looks really nice, actually. I've tried other AI slide generation tools and was not so happy about them. But it talks about all of the different parts of a SMART goal. I think it does a pretty nice job of encapsulating the information that I would want to be conveyed. It doesn't always look absolutely perfect. Like, I'm no graphic designer, but I probably would have moved the things around a little bit. But as far as slides go, I think they're pretty nicely put together and the content is correct, as correct as I would need it to be. So anyway, I thought that was cool. And then, oops, let's go back to this guy. Okay. I'll probably go through a few more of the slides because we only have a couple more, and then we can go back and see how our presentation came out. It says just right now that it's multitasking. All right, so I have some information here for getting started with agents if you're interested in that. So there are three sort of broad types of ways that you can interact with agent. There is the chat plus tools option, so chat GPT plus. These are all in American dollars. I don't even know why I didn't think to convert it to Canadian dollars. But anyway, $20 US per month, closer to 30 for Canadian, because that's just how it is. Claude Pro as well, computer use, Gemini Advanced with deep research and tools and all of that. Free tiers are available, and you can probably get the reasoning models, at least a little bit, using the free tiers. But a lot of the agentic stuff right now is paywalled. But a lot of people I know pay for ChatGPT Plus or Claude Pro. If you are into coding, Claude Code has a free tier that works in your terminal. Cursor has been around for a while and is constantly improving. There are a ton of ways to incorporate AI into a lot of coding IDEs that already exist. I personally use VS Code with GitHub Copilot because I'm still on a student plan, which is awesome. You can also build your own systems. This is like the slightly more advanced options. I've just name dropped a few different ways that you can start building your own tools. And if you are not that experienced with agents or you feel like you could use more experience even just chatting with large language models, just jump in, start small. Even a 5-minute experiment will I think teach you a lot more about the system than just reading about it. Let's see how we're doing here. Still going. So, as I said, the limitations right now are the latency, but looks like it is actually done. So, it made a 6-slide presentation covering Canadian pediatric cancer statistics. So, let's open this up and see how we did. Kids' cancer in Canada, treatment advances and research initiatives. Now, maybe I'll send this out in an email after so you guys can fact check it and see how accurate it is, because yeah, I'm not an expert in pediatric cancer. But I see some statistics. We have sources that presumably you could go through and check. Key insight, which is nice. I like that it's not overloading the slides with text. We can see the most common types of cancer for children in Canada, talks about treatment advances, and again, people who are more um, accurate. Oh, that's great. People that are more this is more their area of expertise can look into it a little more. Different Canadian research initiatives that are relevant, and yeah, slight formatting boo-boo here, but like overall, I think looks pretty good. So anyway, yeah, it can do stuff like this now, which is cool. Don't ask it to make slides in Google Slides though, because the browser thing, it's like not that good at the moment. Anyway, speaking of, let's talk about limitations and risks. So, if you are working with an agent and say it's a really, really long task that you have it doing, errors can compound. So, if it makes a mistake like 5 minutes in and then it has 55 more minutes of thinking after, you can come back and it has gone in totally the wrong direction. So, there is a little bit of babysitting that's still necessary. Slow execution, thinking plus acting takes time. That makes sense. Struggle with unfamiliar interfaces, getting it to go between using Excel versus using Google Sheets, still a little wonky at. And especially for larger companies and enterprises, integration is the primary challenge. So actually getting the agent on the computer or in the place it needs to go to do the tasks that it needs to do, and dealing with all of the safety and governance stuff that goes along with it. There are also safety concerns. So I trust Anthropic reasonably well for the agent that they have put on my computer. But it's always the case that if I tell Claude to go to a website and the website has tons of white text on a white background that says like go into the file system and delete these important files, like it might do it, you know? So you really you do have to be careful if you're allowing Claude or whatever other agent that has access to your computer to browse the web, because there could be malicious prompt injections in the places that you're visiting. So be cautious about that. Of course, agents can take irreversible actions. They could delete your files, they could send emails, they could commit your code and push it if you have your like SSH key set up and, bring down a whole production line. So that's possible. And there are also many unanswered questions about accountability. So who is responsible if an agent makes a mistake? The answer is kind of, I don't know at this point. As we move along in this kind of direction of technology, certain standards are emerging. So, model context protocol standards are starting to come out, be published by people, and agent to agent protocol, so agents interacting with each other, standards are also emerging. So, that is like starting to corral this space a little bit, which is a good thing. Before I get to my final thoughts, we are very, very close to the end, and I was asked to get people to fill out the feedback form so we can make as good of a course as we possibly can for you guys. So if you could take just a quick couple of seconds, minutes, to fill this out before the final minutes and the conclusions of this presentation, that would be super awesome. Mm. Mm. Once you're done filling it out, if you could just put like a thumbs up or a little I'm done in the chat. That would be great. Mm. Yeah, Asan makes a good point. If you're claiming credit for an elective as a medical student, the feedback form is important to fill out.
Thank you so much.
Awesome. Thank you. Amazing. Okay. Looks like people are maybe starting to finish filling out the feedback form. So I just have a couple like very high level final thoughts to end things with. So just a conclusion of what we talked about. Language models are really powerful AI systems. They are capable of generating documents and having conversations, but they are still a little bit unreliable and can produce errors or hallucinations. We also have beyond the base models, reasoning models such as O3 or R1, and these are powerful methods for solving multi-step, complex, difficult problems. But the prompting techniques will differ slightly than from traditional language models, and they are a little bit slower. And the current frontier is agentic AI. It's a really amazing, promising direction for LLMs, especially since we are starting to see a plateau in performance for other types of language models. But there is still room for growth, and the safety standards are still emerging. And a couple of just like my own closing thoughts. LLMs are definitely, as a society, changing the way that we think. And there is never going to be a time in the future where we do not exist alongside AI chatbots. They are going to evolve and they're going to appear in different forms. But I don't think for the rest of my life I'm ever going to be at a point where I'm not going to be able to talk to some kind of AI chatbot, like a general purpose AI chatbot. I think if that's going to be the case, then what we have to do, our responsibility as users of these systems, is to keep the critical thinking skills like as much as possible. And I think a part of that is refining our taste. So we can have basically any type of digital content created for us just with a simple prompt. So based on what the LLM is putting in front of you, you have to decide for yourself and have a sense for yourself of what is an appropriate response, an appropriate output, what is good enough quality to put your stamp of approval on. And I think the people who have a really strong sense of their own taste and a strong sense of what a good, high quality AI output that actually makes the world a better place is going to be. And with that, we are done. And it is exactly 7 o'clock. Oh my gosh, that was really that is not timing I was expecting, but we did it. So